Hey, this is Mr. Aiden. This is AB Calculus AB, and this is Unit 8 Applications of Integration. We're going to be taking a look at area between two curves and what that looks like. If you remember the last video, we took a look at the area between a curve and the x-axis, and we started to take a look at what happens when we have two different curves going on here. So let's take a look at this function right here. This is, obviously, we have a sine function in red, we have a cosine function in green, and let's call this guy up top, we're going to call this y equals f of x. The green one is going to be the function of x. This red one is going to be, we'll call this g of x here, this red one, this sine function right here. And so let's take a look at two values here. We're going to take a look at a, and we're going to take a look at b right here. Okay, a and b. And so if we take a look at this interval a and b, and we want to find the area between these two curves, between a and b, we're trying to find out the area right in here, if you can see. So the area between a and b of this value, okay, is going to be the area from a to b of my function f of x dx. Okay, that would give me all the area from the green all the way down to the x-axis right there. Okay, and obviously what are we going to do is we're going to subtract the area from a to b, or the integral of from a to b of g of x dx, which is this area right here in the x-axis. Can you see how if we take this full area of green and this little area of red and we subtract them, we get this area in the black right here, which is simply the area, let me do this in black right here, is simply the area under the curve right here. Okay. Now, what does this mean? This is the same as the integral of a to b of f of x minus g of x dx. And so we're subtracting those two functions and finding the integral there. And obviously, you can see the area of, I'm going to put some numbers. Obviously, these numbers are not right, but I'm going to put some numbers to these. Let's say the area underneath this green curve is 10. And let's say the area underneath the red curve is 2, which means the area would be 8 overall, just this little area right there, because we had a very big positive magnitude of the green, a very small magnitude of the red, and we subtract those and find out the leftover magnitude. Now, what happens if we are going to take different intervals? Let's say we're taking the interval of c to the interval of d. And we want to find the area between these two curves. Okay, we're trying to find out the area of both of these guys. And together, this area is going to be much, much, much bigger. But what are we doing here is we're going to take the area of the upper function. We're going from c to d. And I'm going to erase this guy right here. And I'll make this guy a little bit higher here. We're going to go from c to d of g of x dx, the one on the top, okay? And that is going to give you this area right here, okay? From g of x to the x-axis right there. And we're going to subtract the lower function, and the lower function is going to go from c to d of, the lower function is my f of x dx, okay? And that would be this area, this negative area right here. And so what is that going to be is that's the area from c to d of g of x dx minus f of x dx, and that would give me my area. That would give me my full area in between. So let's put some numbers to this, and that way it'll make some sense. Maybe logically is, let's say the area of this upper function is positive 5. Let's just say. Now, obviously these numbers aren't right, but I'm just giving some numbers to it to put some context to it. And this area on the bottom is negative 5 because it was below the axis. Do you see this negative 5 minus negative 5 ends up giving me a total area of 10, which would be the total area in between both of these functions. The area from here to here, all the way here, and in between all of that area, in between all of that. Okay, and that would give you that area, that total area. I think I said that like 5 times in a row. So let's go to a last interval here. We're going to go to a little bit more difficult of an interval. Let's call this interval, we'll call this E to F. E to F. And we're trying to take a look from E to F, the area in between these two curves. Now think of what the area between these two curves is. The area between these two curves is this smaller area right here, isn't it? Okay, that's between those two curves. Now let's think about what this looks like in terms of my integrals. Okay, I have my upper function is my f of x, isn't it? My upper function is my f of x. And so we're going to go from e to f of x dx. And we're going to take away, remember that's the integral right here. That's the area right there. And then I'm going to take away from e to f of g of x dx, which is all of this right there. And what is that going to result in? That's going to result in a little bit simpler of a version, e to f of x is the one on the top minus g of x on the one on the bottom, dx. And so let's put some numbers to this, and that way we can kind of understand what's going on. This green function, let's say this green function, I didn't want to do that in black. Let's say this green function ends up giving me, I still did it in black. Oh no, change my color. So let's say this green function right here ends up giving me -3 because it's below the x-axis. It's going to be an area of -3 minus this red one. Let's say this red one totally is going to be -8. Now what happens is -3 minus -8 is really -3 plus 8, which is an area of 5. The area underneath is 5. Now you might say, why isn't this area negative? This area is below the x-axis. Remember, this is just the area between the two curves. It's not giving us direction here. It's just the area between the two curves. And so this is how we find the area between two curves is we take the upper function minus the lower function, and we take the integral of that. So let's put some problems to this. Okay, we're going to take a look at what is the area between the two curves of f of x. And so my f of x is this one right here on the top. We have our g of x is this one right here in red, g of x, and we want to find the area between these two curves. The area between these two curves from -1 to +1. So what are we trying to find out is we're going to try to find out this area in between these two functions. So we're going to take this area in between these two functions right here. Okay, all of this area in between there. So what are we doing to find this area? Well, we're going to take our integral. And our integral is going to go from -1 to +1. My upper function, my f of x, stays valid the entire time. It's on the top, all the way from -1 to +1. The g of x is on the bottom, all the way from -1 to +1. So we can keep consistent here. And so what do we have here is we have -1 to +1 of x to the 4th minus 4x squared plus 1 minus x squared minus 3 d of x. Now watch out with your calculators here. This is a little note for your calculators. Make sure you put this second guy in parentheses because this negative goes to everything in there. That negative is subtracting that function. And so don't just put negative x squared minus 3 because what is really happening is this negative is going to the x squared and the negative is going to the -3, which makes it plus 3. And if you do this on your calculator, try this out on your calculator, you would end up getting 76/15 is your area between these two curves, 76/15. Okay. Remember, your area under the curves is always going to be positive because we're just looking at what's the area. We're not looking at positive or negative areas. Those positives and negatives will come to play within your integral or your equations. Okay. Now here we want to find the area enclosed by these three curves. Okay, so think about what's happening here. We're trying to find the area enclosed by the three curves. So we have this green curve, this red curve, and this blue curve. What's the area in between is all of this area in between here. Okay, that is the total area that I'm trying to find. So let's think about what's happening here when we're doing our integral. What we really need is, we can't just do this in one equation, because my green function, this square root of x, is on the top here. The blue function right here is on the bottom here. Then you can see the red function goes on the top, the green function's out of play, and the blue function is still on the bottom. So we kind of have to split this up into two integrals, don't we? We got to split this up into two integrals. So our first integral is going to be from 0 to 1, 0 to 1 on the x-axis. Who's on the top is the square root of x, this f function, minus who's on the bottom is this x squared over 4 minus 1, this function right here called h. So this was the integral from 0 to 1 of f minus h dx in terms of my functions. Now, we also have another function here, so we can put a little plus symbol. Plus symbol, we're going to add up the area of these two functions. What's the other function is going from 1 to 2, and who's on the top is the g function, which is 2 minus x. Who's on the bottom is this blue function, which is x squared over 4. That looks awful in terms of my writing, so I'm going to rewrite that. X squared over 4 minus 1 dx. Okay, and what are we really doing there is we're going from 1 to 2 of my g function minus my h function d of x, aren't I? Now I can do this on my calculator. And so on the calculator, if you do this from 0 to 1 of the square root of x minus x squared over 4 minus 1 d of x, you end up getting 19 over 12. Okay? Now the next function, from 1 to 2 of this function, we end up getting 11 over 12, which ends up, if you add that up, is 30 over 12, or reduced to 5 over 2. And that is the area under the entire curve, 5 over 2. Or 2.5. So what did we do? We took the area of one of the functions and the area of the other function, and we added those up together. We always put the upper function on the top minus the lower function on the bottom. Take that integral, and that's the area between two curves.